Hello, good morning. I am Dr. Ashok Kumar. I am working as an assistant professor of chemistry in Government Girls Degree College Kharkhoda, which is affiliated to Chaudhary Charan Singh University, Meerut. In this lecture, I am going to present the topic Bohr's model of atom. Whatever we see around us is matter. Matter is made of very small particles which are called atoms. Experimental observations around the end of 19th century revealed that atom is composed of subatomic particles. The main subatomic particles are electron, proton and neutron. Electron and proton are charged particles while neutron is neutral. In order to explain the distribution of subatomic particles in an atom, some atomic models were proposed which include Thomson model, Rutherford model, Bohr's model and quantum mechanical model of atom. According to Rutherford's model, proton and neutron are concentrated in an extremely small region. This small region is called the nucleus. Electrons revolve around the nucleus. Electrons are bound to the nucleus by the force of attraction. However, there were some drawbacks in Rutherford's model. It could not explain the stability of the atom. It also could not explain how the electrons are arranged around the nucleus in an atom. Niels Bohr utilized the quantum theory of radiation to overcome the objections raised against Rutherford's model. Bohr's model was based on some postulates which we are going to discuss one by one. Postulate 1. Electrons revolve around the nucleus in a circular path of definite radius and energy. These paths are called orbits, stationary states or allowed energy states. Orbits around the nucleus are represented by the capital letters K, L, M, N and so on, or by the whole number 1, 2, 3, 4 and so on. As the distance of the orbit from nucleus increases, the energy of the orbit also increases. Postulate 2. The energy of an electron in the orbit doesn't change with time. It means as long as electron revolves around the nucleus in the orbit, it doesn't lose its energy. However, the electron will move from lower stationary state to higher stationary state when energy is absorbed by the electron, or energy is emitted when electron moves from higher energy state to lower energy state. The energy of the radiation must be exactly equal to the energy gap between the two energy states. If the energy is less or greater than the energy gap, electron will not absorb the energy and there will be no electronic transition. Postulate 3. The frequency of radiation absorbed or emitted when transition occurs between two stationary states that differ in energy by delta E is given by the equation frequency mu is equal to delta E upon H or E2 minus E1 upon H. This equation is called Bohr frequency rule, where E1 and E2 are the energies of the lower and higher energy states. As it is clear from the equation that the frequency of radiation depends upon the energy gap between two energy states. If the energy gap is higher, the frequency of radiation would be higher. Postulate 4. The angular momentum of an electron in a given stationary state can be expressed as mvr is equal to nh upon 2 pi, where n is an integer having values 1, 2, 3, 4 and so on. Thus, an electron can move only in those orbits for which its angular momentum is integral multiple of h upon 2 pi. That is why certain fixed orbits are allowed. Conclusion. In conclusion, it can be said that Bohr's model was no doubt an improvement over Rutherford's model. Bohr's model could explain the distribution of electrons and stability of atoms. However, there were some drawbacks in Bohr's model. It could not explain the fine spectrum of hydrogen atom. It is also not in agreement with Heisenberg's uncertainty principle. That is all in this lecture. Thank you.